Years ago, people went to great lengths to make rope. They stretched yarn hundreds of meters, sometimes down alleyways, and secured it on hooks. Then they turned the wheels to rotate the hooks, twisting the yarn into rope. This technique was called a rope walk. Luckily today, we have machines to do all the legwork. These ropes are made from thousands of nylon fibers that are finer than human hair, but stronger. To make rope, yarns are wound around aluminium cylinders, pulled by a turning spool. Then, 3 at a time, the yarns roll over another spool that applies a protective coating of urethane. They funnel through a distribution plate that holds them evenly apart. This ensures they're at an even tension as a rocking spool twists them into one larger yarn. This machine is called the whirlwind. It twists the yarn and then winds it onto a take-up spool inside. A small arm moves back and forth, guiding the yarn so it winds evenly onto the spool. This is core yarn, and it will be used to make other rope. Now, dozens of spools of nylon fibre unwind at the same time to make jackets to protect the core yarns. The fibres travel several meters over a network of rollers that act as guides and control tension on each individual fibre. They pass through distribution plates, as turning bobbins below twist the fibres into yarn. A platform moves up and down to evenly wind the yarn onto the bobbin. 48 of these bobbins are placed on the maypole machine. The braiding action tells you where it got its name. The bobbins spin and zigzag around each other as the machine pulls core yarn up through the centre. Here you can see the rope being braided around the core yarn as it's pulled up through a die. This is the braiding action in slow motion. It produces a mountain climbing rope, strong yet stretchy because of the twist in the core of the rope. The rope winds onto the wheel as it pulls it upwards. Then it spills into a basket. A sample rope is pulled out and its flexibility and strength are checked. Now, another maypole braider weaves a synthetic rope that's stronger than steel, yet lightweight and flexible. That's because the strands at the core are braided with a material called ultra-high molecular weight polyethylene. It's a high-performance thermoplastic. This rope will be used for yachting. A pulley draws this high-tech rope through some metal pipes filled with steam. This shrinks the polyester jacket around the powerful core for a tight fit. These dancing bobbins perform some fancy moves to produce different weaves around core ropes. They dip around and between each other in a choreographed sequence. If a yarn breaks, the machine simply shuts down. It takes 9 hours to make around 900 meters of this large utility rope. To test its strength, a sample piece of rope is looped around steel posts. This one is a nylon double braid, the type used for dock lines on boats. Hydraulic pressure pulls the rope upwards, while a computerized gauge measures the tension and detects the breaking point. Over 9,000 kilograms. That's the weight of a killer whale. Needless to say, this twine is just fine. In another test, a steel probe known as a FID is inserted into some industrial rope, and the pointed end is placed into a hole. An electric motor forces the FID through, while a gauge measures the force it takes for it to completely penetrate the rope. It took 4.5 kilograms of pressure to push the probe through the rope, which means this rope is firm yet flexible. So now, you really know the ropes about rope.